Students, in class 8 you have learned algebraic expression, and in class 9 you have learned special case of an algebraic expression, that is polynomial. We can define a polynomial in one variable as an algebraic expression with the exponent of the variable is a non-negative integer, and the highest exponent appearing in the polynomial is called the degree of the polynomial. General form of a polynomial of degree n is a0 plus a1 x raised to 1 plus a2 x raised to 2 plus an x raised to n, where this a0, a1, a2, etc. are all real numbers called coefficient, and n is highest exponent, and therefore it is degree of this polynomial. And also we know that an algebraic expression or polynomial that contain exactly 1, 2 and 3 terms are respectively called monomial, binomial and trinomial. Like that, depending on the degree of a polynomial, we have linear polynomial, quadratic polynomial and cubic polynomial. We define linear polynomial as a polynomial of degree 1. A polynomial of degree 1 is called a linear polynomial. General form of polynomial of degree 1 is ax plus b, x raised to 1. So degree 1, it is general form of a linear polynomial, and here a should be not equal to 0. Example of linear polynomial are 3x plus 7. 3x plus 7 is in fact linear binomial. 10x is example of linear monomial. A polynomial of degree 2 is called a quadratic polynomial. General form of quadratic polynomial is ax square plus bx plus c, where a not equal to 0. If a is equal to 0, then this will reduce to bx plus c, which is a linear polynomial. Therefore, your condition a not equal to 0 is important. Example of quadratic polynomial: 4x square minus 5x plus 1. Degree 2, 4x square minus 5x plus 1 is a quadratic trinomial, and 6x square plus 19 is a quadratic binomial, because degree of this polynomial is 2 and it contains 2 terms. Therefore 6x square plus 19 is a quadratic binomial. A polynomial of degree 3 is called a cubic polynomial. General form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a not equal to 0. And examples here are x cube minus 7 is cubic binomial. Then we have here 2x cube minus 8x square plus 6x minus 5. In case of polynomial, we can use some other variable as variable y, a, t, etc. Students, note that degree of constant polynomial is 0 and degree of 0 polynomial is not defined. Constant polynomial is a polynomial independent of x, just a real number, and 0 polynomial is 0, real number 0. So we have here degree of constant polynomial is 0 and degree of zero polynomial is not defined. Now let us see to find the value of a polynomial. We have here for real number k, the value of polynomial px at x is equal to k is denoted as p bracket k. Let us consider some example to find the value of polynomial. First one, find p minus 2, that is value of polynomial p at x is equal to minus 2, and here p of x, that polynomial in x is x cube minus x square plus 3x minus 1. To find the value of polynomial at x is equal to minus 2, what we have to do is we have to substitute x is equal to minus 2 in this. So we'll have this thing as a skeleton of this polynomial. Here I will substitute x is equal to minus 2, and what we'll get is p bracket minus 2, that is value of the polynomial at x is equal to minus 2 is equal to minus 2 cube minus minus 2 square plus 3 into minus 2 minus 1. Here first we will simplify minus 2 cube minus 2 square, that is we will find the value of minus 2 cube and minus 2 square. Minus 2 cube means minus 2 into minus 2 into minus 2. Minus into minus is positive, into minus is minus. So here negative, and 2 cube, 2 multiplied by 2 is 2 to the 4, 4 to the 8. So minus 2 cube is equal to minus 8. Like that, minus 2 square is minus 2 into minus 2, negative into negative positive, 2 to the 4. So minus 2 square is 4, plus 3 multiplied by minus 2 and minus 1 I am writing as it is. Then next we have minus 8, minus of that plus 4 become minus 4, plus 3 into minus 2, plus into minus gives you minus, 3 to the 6, and then minus 1. Minus 8, minus 4, minus 6, minus 1, all these integers are of same sign, that is negative. Therefore the answer is negative. 8 plus 4 is 12 plus 6 18 plus 1 19. So answer will be minus 18. That is value of the polynomial at x is equal to minus 2 is minus 19. Let us consider one more example. Find the value of polynomial px is equal to x square minus 2x plus 1 at x is equal to 1. That is what we want to find is p of 1. I'll substitute x is equal to 1 in the left hand side and the right hand side. Here what we'll get is p1 is equal to 1 square minus 2 into 1 plus 1. Then 1 square is 1, minus 2 into 1 is 2 plus 1, and then plus 1 and this plus 1, 1 plus 1 become 2, 2 minus 2 0. So value of the polynomial at p is equal to 1 is 0 in this case. Third example, find the value of the polynomial px is equal to 3x square minus 8x plus 9 at x is equal to 0. So you will putting x is equal to 0, what we will get is p0 is equal to 3 0 square minus 8 multiplied by 0 plus 9. We know that 0 square is 0. So what we will get here? 3 into 0 minus 8 into 0 plus 9. And any number multiplied by 0 gives us 0. So we have 3 multiplied by 0 is 0, minus 8 into 0, that is 0, plus 9. And this comes to be equal to 9 only. So p of 0 is equal to 9. Then we have a definition here. A real number k is said to be 0 of a polynomial px if and only if p of k is equal to 0. That is, value of the polynomial at x is equal to k is equal to 0. Then that real number k is said to be 0 of the polynomial. In the example 2, we can see that p of 1 is equal to 0. That is, value of the polynomial x square minus 2x plus 1 at x is equal to 1 is equal to 0. Therefore, we can say that 1 is 0 of polynomial x square minus 2x plus 1. Students, note that in third example, p of 0 is equal to 9, and therefore this 0 is not the 0 of polynomial 3x square minus 8 plus 9. Real number 0 is not 0 of this polynomial 3x square minus 8x plus 9, because value of this polynomial at x is equal to 0 is 9, which is not equal to 0. Last year in class 9, we have learned to find 0 of a linear polynomial. In general, 0 of a linear polynomial of the form ax plus b is minus b upon a. In next video, we will learn to find 0 of quadratic polynomials.